Solid-state batteries are coming. They offer increased safety and higher energy density, but they come with some challenges. They need to be kept under pressure to ensure that the layers maintain contact, but they expand and contract during operation, so maintaining that consistent pressure is not easy. Don't take my word for it. Listen to Jerry.
My name is Jerry Dixon. I work for Schaeffler Group USA. We're a global automotive supplier, and we specialize in a variety of different technologies. And one of our recent development areas has been in solid-state batteries. So we took a lot of our knowledge and information from some of our automotive divisions, and we were able to develop our own in-house produced solid-state battery cells. This is a real actual solid-state battery that we produced in-house, and from that we were able to learn a lot about the technology. One of the major developments that we found was that for solid-state batteries to be able to work effectively, they need to be pressurized. If we want to get more and more charge and discharge cycles out of a solid-state battery, we need to make sure that we apply a significant amount of pressure to them. And so we took all of our mechanical knowledge, our stamping knowledge, our automotive production knowledge, and we were able to create a solid housing cell. This is a cell where the plates are individually located here, and then we have a nested cylinder application where the cylinders are able to expand and contract. So we pressurize these cylinders, they apply a certain amount of pressure on the individual cell pack, and then as a solid-state battery charges and discharges, it actually grows and shrinks, and so we have to accommodate that growth and shrink. It can be 20 to 30% growth or expansion as we go through with that. So these cylinders had to accommodate for that as well. When we do this, we have a couple of different applications. So one of them is nitrogen cells, the other one is a hydraulic system, and both are interesting for either an automotive market or also a humanoid robotics application. So if I walk you through the humanoid, it's the same exact cell structure. We have the same technology capability with either a hydraulic or a nitrogen-based system, but what we have noticed is that we went for power density on here. So this, as an example, is a lithium-ion battery pack, and you can see just from the general size that this humanoid pack is roughly twice the size, but it has 4 times the capacity for the overall state of charge in this application. And it's a 10% weight reduction in compared with an equivalent system like what we have here. The passive and the active, the difference there is the hydraulic system versus the air system. So in an active system, if you wanted to charge a system rapidly, then with a hydraulic setup, we could turn the pumps on, and that would start to pressurize the overall nested cylinders inside of it, and we could increase the pressure on the batteries, and that's going to help it take a charge faster and be more capable during an aggressive charging or a fast DC charging, as an example. With a passive system, it's going to charge a little bit slower, but it can also be a cheaper system and might work for another application. Having good pressure on a solid-state battery and making sure that pressure is consistent across the whole entire surface is one of the keys to ensure that you can get longevity out of the batteries. So you don't want to have 100 cycles of charge and discharge and then the battery goes dead. You want to have 3,000 or 10,000 charge and discharge cycles, and that's what our housing technology has been able to help us enable. Once we made our first cell, we said, how do we make our first pack? As we tested our first packs, we realized that the charge and discharge cycles were poor, so we needed to innovate and we needed to develop something to be able to improve that. That's where the pressurized systems came from, and then we knew that they were going to expand and contract as they charged and discharged, so we needed to design a solution to be able to fit with that. So we applied other technology from our other businesses to this to be able to come up with an innovative solution. All of our work is being done in Worcester, Ohio. We have a battery research and development system there. We have a joint venture with Ohio State University as well for a battery cell development site through the university or with the university.
Great. So even in a world with electric vehicles and batteries, there's still need for mechanical and engineers.
That's absolutely it. That's the fun part. I'm a mechanical engineer by trade, and I got involved in solid state batteries. The chemistry is not my expertise, but the mechanical systems are, and you can see that we're applying mechanical systems to the batteries and to the electronics.
Well, I'm also a mechanical engineer, so I'm glad there's a future for us.
Absolutely.
Thanks for the overview, and can't wait to see it. Will you be at CES again this year?
Yes,
All right.
we will. Yep.
Maybe I'll run into you there.
Great.
Thanks so much.